Hey guys, what's up? Threads13 here for deucescrack.com, coming to you today with the first episode in the new mini-series Tolerance. What we'll be discussing in this series is how to become tolerant of variance. And to do that, we have two distinct things we'll be looking at. One, what is variance? We'll be getting into that, working with a lot of math and examples, theory, things like that. And two, we'll be talking about shifting our focus from something other than the results and variance, and specifically onto learning. And we'll be talking about how to maximize our learning so that we essentially have more of our focus on the learning and less of it on the variance. And this just means, one, our win rate will be higher and we'll have less variance. And two, we won't have as much attention to really pay to variance in the first place. So, more specifically, the first episode will be discussing win rates, standard deviation, and mathematical variance. So we'll discuss what a win rate is, what variance is, what standard deviation is, and we'll discuss using these numbers, how they all work together, how they all affect each other, and therefore what is fair to expect. What sort of results should we see? How bad can it be? How break even can it be? How good can it be? How do sample sizes affect all this? We'll be doing a lot of examples like that to just let you see what you can expect. Because the thing is, I think a lot of poker players really don't realize how intense variance is. I think it's partly variance's fault because it's pretty intense, and I think it's partly our own fault for not really just looking at it and spending time with it to try to really wrap your heads around it. It's hard to do. It's hard for the mind to kind of conceive it to begin. But I think if we work at it, then it becomes easier. And if we can understand it, it kind of takes a lot of its power away. We can kind of step back and be like, that's just variance. And it won't bother us as much if we are able to do that. So hopefully at the end of this episode, you guys will be able to see, an answer to the question, how long is the long run? Because the thing is, it's really long. Said we all pay a lot of lip service to it, but if we really dig in, I think that'll give you guys a great understanding of it and will just make you a better player. So that'll be the first episode. The second episode will discuss recognizing variance and its effects. So we'll talk about identifying variance in real time. What I mean by that is we'll see, we're playing a hand and a result happens and we can identify it immediately as variance. And I think this is important because we have to understand how this can affect our mind. So to be a little more specific, say that, you're in a situation where you make a bet and it was the correct play and it doesn't work out and we recognize that as negative variance. Then we can move on. If we don't recognize that, then we can have a tendency to think that it was a bad play, especially if this happens several times in a row. We can start thinking, well, that must be a bad play. What we should be thinking is, are my estimates off? That's the only thing we can get from observation is, are we misestimating folding ranges and so on, whatever it may be. Are our estimations off? And if they're on, then the play was good. If they're off, then we can work on that and play better. So, and in all this, we'll discuss comparing our results to EV. So we'll see, it's like you can see over short samples how you can just have some high variance results one way or the other that can be really far from our expected value. And you'd be surprised like how just a couple high variance big bet sort of situations can really affect the EV of the not the EV, I'm sorry, but the result of a session. So sometimes a session can come down to a handful of high variance situations that either did or didn't go your way. And so you can kind of just take that away, and then the results of a particular session won't have so much of an effect on you. In the third episode, we'll start talking about the learning process. So we'll discuss how do you learn, and specifically learning in small chunks. Now, what do I mean by that? I mean, poker is a really complicated game, and there's a lot of knowledge out there to acquire. And if you kind of think of that knowledge as this big mountain that you have to climb, you wouldn't try to climb it by just jumping right to the top, right? You couldn't pull it off. It doesn't work. What you have to do is start at the bottom, learn those big chunks, that really foundation of it all. Get that down. And then once you do that, you can move up higher on the mountain, and then you can get that down. You can't work on this stuff all the way at the top until you have the stuff at the bottom down. And this mountain is really, really big. So what you have to do is just keep working on these small things that you're learning, keep getting a little bit better, and the next thing you know, you'll be at the top looking down going, wow, like I really learned a lot of stuff. I can't believe how much I did, how much I've learned in such a small period of time. That's how it's going to seem. So, and in discussing this, we'll discuss the conscious competence learning matrix, which I think is a really cool concept for you guys. And I think it'll really help you kind of understand how the human mind learns things. Again, if you can understand something more, it's going to be easier for you to work with it, easier for you to be maybe a little more patient with yourself. And again, you'll just be a better player for it. We'll discuss the pre and post session routines and how this kind of all fits into, learning. And we'll discuss setting attainable goals, specifically discussing setting learning goals. I think it's a really bad idea to be setting a goal like something, I want to win X amount of money over my next 20,000 hands. And as we'll see in the first two episodes, it's kind of a ridiculous goal because there's so much random variance involved that has nothing to do with you. You can't say I want to win so much over my next 20,000 hands as a goal because you don't have control over your results. All you have control over is like your long-term results, and 20,000, as we'll see, is not nearly long-term enough. So if we're going to be setting short-term goals for ourselves, it can't be based on our results. It can only be based more on our learning. So we'll discuss learning things that you can work on. So for example, maybe you need to work on thin value betting to turn, just picking some sort of concept arbitrarily. And then you can focus on learning that and let your how well you did on applying your knowledge while you were playing, let that be your guide. If you did really well, that was a good session for you. If not, you get back on the horse and try again. But none of this is going to be your results. And if you're just essentially focusing hard on this, it becomes easier to be tolerant about all that variance that's going around. In the last episode, we'll be discussing developing a learning plan. I'll be giving you guys some examples of a pre-session routine and a post-session routine for me, just kind of so you can see what we're talking about in action. And we'll discuss what I call the session cycle. And I know this is a little vague, but we'll get into it in the fourth episode. So, stick around. And we'll discuss executing your strategy, which, again, we'll get into it more in the fourth episode, but it is more, working on the things you need to be working on to make yourself better. Then we'll discuss how to analyze hands a little bit. Using spreadsheets. Again, I'll be kind of demonstrating this in a session of my own, so you guys can see how to do that. And using PokerStove as well. And then we'll discuss just taking time off. Poker's a hard game, and if you spend a whole bunch of your energy on it, then you can kind of wear your brain out to where you're not learning anymore. You're kind of treading water, and then maybe even getting pushed backwards a little bit because now you're not working on new stuff and things kind of become dull. You aren't as sharp. So we'll discuss all of this and how you can essentially make the most of your learning. So with that said, we're going to move on and start getting into the variance stuff in the first episode. So, what is win rate? A player's win rate is the average amount he or she wins per some sample size or time, hourly. It is most commonly expressed in terms of big blinds per 100 hands, which here as BB per 100. In terms of statistical calculations, this is our mean. So, win rate, mean, even EV, all of those are kind of the same thing, same term, just kind of I'll use them interchangeably. Mean? This guy knows the mean. No, that's not how we denotate the mean. We denotate the mean via the Greek letter mu that you'll see on the right here. So calculating the mean. We calculate the mean by simply multiplying the probability of all the events by their respective value and sum the results. So say, firstly, we'll be doing a lot of examples like this because a lot of this stuff is a bit abstract until you put an example on it. So I'm going to be going through a lot of examples. So in this instance, we're going to talk about calculating the mean of a coin flip as a simple example to understand how we calculate the mean. So let's give heads a value of 1 and tails a value of 0. And of course we assume that the probability of heads and tails is both equal to 50%. So we have the mean here. P of heads is probability of heads times the value of heads, and we add that to the probability of tails times the value of tails. Then we just plug in our numbers into this equation. So the mean will equal 0.5 times 1 plus 0.5 times 0. And of course this works out to be the mean is equal to 0.5. What is the variance? Variance is a mathematical measurement of how far the results may fall from the mean. Now note on this, you will often hear people in the poker community talk about variance, and what they're often talking about is specifically negative swings. And I think this causes some ambiguity. But this is only half of the true mathematical definition. There's positive swings, there's positive variance, and there's negative swings, negative variance. It goes both ways. Many poker players, tend to downplay positive variance and exaggerate negative variance. This may have something to do with why variance always has to mean negative variance, because poker players tend to think, well, they don't really have much positive variance, only negative variance, but we do have both. And this sort of view can kind of like skew your outlook on the game. And we'll get more into this later, but just a word on it for now. So, calculating the variance. This is a bit of a mouthful, and I think an example will help, but variance is defined and calculated by multiplying the probability of an outcome by the square of its distance from the mean. Sum this number over all possible outcomes and you have the variance. So, first the equation, variance. Essentially, take the quantity of the value of the outcome and then subtract the mean, square that number, multiply that times the probability of the outcome. Now do this for every outcome and add them all together. So again, to an example, using a coin flip example, where the mean is equal to 1/2, value of heads is equal to 1, and value of tails is equal to 0, we can plug this all in here. So probability heads times value of heads minus the mean, square that. Do the same thing with the tails. I won't walk you through all the math for this one, but definitely pause the video, take a look at this, make sure it all makes sense to you, because we're going to come back and use this when we start talking about some specific hands and calculating the variance for that specific hand, so that we can illustrate how much variance there is in the game. So go ahead and look through this. Like I said, pause the video, but variance will come out to be 1/4. What is the standard deviation? It's the square root of the variance. That's how you find the standard deviation. So to find the standard deviation, first you calculate the variance, and then you take the square root of it. Reason we do this is it's more useful than the variance. With the standard deviation and win rate, aka mean, we can mathematically determine what to expect from results. You'll see also the standard deviation is often denoted by the Greek letter sigma on the right here. So going back with our example, the standard deviation of a coin flip is just the square root of the variance, which was equal to 1/4. So we get 1/2. Using the standard deviation, you can easily use the standard deviation to find the probability that an observed sample will fall in a certain range. In a normal distribution, a result will be within one standard deviation from the mean 68% of the time. This means is add one standard deviation to the mean and subtract it. That range of number, that's where your results will lie 68% of the time. Two standard deviations of the mean will hold 95% of the results. Three standard deviation mean 99.7% of results. So you can see 3 standard deviations from the mean will hold almost all of the results. And a good chunk of those results will fall just within 1 standard deviation. So, scaling, what do I mean by that? You can easily scale these numbers so that you can take a look at how results can change over larger and smaller sample sizes. You can easily scale the mean and the variance by multiplying to get the desired sample size. Note it's the mean and the variance, not the mean and the standard deviation. So let's take a look at an example at how to do this. So take a poker player with a win rate of 4 BB 100 and a standard deviation of 60 BB 100. These are pretty sort of normal numbers to run at in like a no limit hold'em game today, So, what is his mean and standard deviation over 50,000 hands? Mean is really easy. All we have to do is scale to get the mean per hand, So, to do that, we just take our mean that is 4 BB 100 and divide that by 100. And we get that at 0.04 BB a hand. If we want to look at 50,000 hands, we just multiply that times 50,000. So 50,000 times 0.04 is equal to 2,000 BB. Standard deviation, a little bit different. Remember, we have to scale the variance, not the standard deviation. We're given the standard deviation because most of your guys' poker softwares will give you the standard deviation because, like I said, it's more useful. The only time we really need the variance, honestly, is when we're talking about scaling these numbers. So, since we start with the standard deviation, first we have to find a variance per 100 hands. Then we can find the variance per hand, and then find the standard deviation per 50,000 hands. So, to get the variance per 100 hands, we just take the standard deviation and square it, because standard deviation squared is equal to the variance. So, we do that, we get variance per 100 hands equals 3,600. To get the variance per hand, again, all we have to do is divide by 100. So, variance per hand is equal to 3,600 divided by 100, which equals 36 per hand. Thus, the standard deviation per hand would equal to square root of 36, which is equal to 6. Okay, and now we simply multiply our variance per hand, which is 36, by 50,000 to get our variance per 50,000 hands. We then take the square root of the result to find the standard deviation per 50,000 hands. So, variance per hand, 36, multiply that times 58,000, we get 1.8 million. take the square root of that, and now we have our standard deviation per 50,000 hands, which is equal to 1,342. So we have the mean, 2,000 BB, standard deviation, 1,342 BB. What we can see here is as the sample size increases, the mean overtakes the standard deviation. Specifically, at 100 hands, the mean is 4 and the standard deviation is 60. So the mean's like 1/15? Yeah, 1/15 of the standard deviation. At 50,000 hands, the mean is 2,000 and the standard deviation is 1,342. So the mean is now getting close to about twice the standard deviation. The thing is, you'll see that when the mean is larger, the standard deviation has less of an effect on it. So that means the results aren't going to get as far from the mean. So, said another way, as the sample size gets larger, the results will gradually converge on the mean. This is the concept often referred to as the law of large numbers. Now, the thing I really want to drive home here is the larger the mean is in relationship to the standard deviation, the less swingy the results will be. It's this relationship between these two numbers that determines how wide a range our results will fall in. The reason why I want to get on this is because a lot of players have, and you'll hear this, and maybe you've said it yourself, say something like, well, this may be a positive EV play, but it's going to increase my variance, so I'm going to pass on it. Well, the thing is, if you increase your win rate, then the sooner your win rate is going to overtake your standard deviation, which means the sooner you're going to converge on the mean, which means the less results you're going to have, less swingy results you're going to have over smaller samples. So increasing your win rate actually will decrease your variance. Getting back to the example, in any given 50K hand sample, the results will lie between one standard deviation, 68% of the time, so this is in the range of 648 BB and 3,342 BB. The two standard deviation, 95%, will be negative 684 BB and positive 4,684 BB. And the 3 standard deviation, 99.7% of the time range, will be negative 2,026 BB and positive 6,026 BB. The trouble with win rates? Our observed win rate is unlikely to be our actual win rate. Why? Our sample size is almost always too small. We'll see this in some further examples, but it takes a long time to acquire a reasonable sample size. And the thing is, as you try to take a long time and get this sample size, a lot of time has passed. If a lot of time has passed, you've probably gotten better. The games might have changed. You might be playing at even a different site. So all this is going to affect your win rate. And also, there's times where your own, your own playing ability is changing just from day to day. Some days you play better, some days you play worse, some hours you play better. All this is going to tend to make your win rate rise and fall. So we're looking at a sample where your win rate is going up and down and around. We're getting somewhat of an average, but you're also doing this over, you need a large enough sample size such that the games are changing and you are changing. So there's just too many variables to be able to get a real accurate depiction of what your win rate is right now. You really just can't do it. Best you can do is estimate based on previous large sample sizes. So let's take a look at an example with a theoretical 2BB 100 winner. I say theoretical because, again, we can't really observe and know that a guy is. But right now we're just going to assume that, for the sake of this example, that we somehow know. So let's take this player, Sammy Supernova, who we somehow know runs at 2 BB100 and with a standard deviation of 70 BB100. Let's take a look at the range of outcomes we can expect from Sammy over his next 100K hands, which is a light month for Sammy. I computed his mean to be 2,000 and his standard deviation to be 2,216. Along with these numbers, we can use the normal distribution to find Sammy's chances of having results in certain ranges. The first thing we're going to ask is, how likely is Sammy to run hot? And I'm going to show you guys how to do that using the normal distribution. So I'm going to break away from this for a minute and going to go on the internet to something I will provide later on, but this is the normal distribution. And what we do here, and I'm going to go ahead and just clear out these numbers for you guys. And what we do is we had our mean right here, and we punch this into 2,000. We have the standard deviation of 2216. So we can just punch those numbers in here. And if we want to find what the probability is of Sammy winning at least twice his win rate, what we're going to do is find results where his win rate is above, which means more than, of course, twice his win rate, which means he wins twice as much as his mean, which will be 4,000 then. 2,000 times 2. Punch that in right here, and it just shows us right down at the bottom that the result will be 18.3%. Cool. Sorry about that. Now going back to the presentation here. So, as we just calculated, how likely is Sammy to win more than twice his mean win rate? He will exceed twice his mean win rate 18% of the time, given a 100,000 hand sample. Months like these can easily skew our perception of win rate. Poker players have a natural tendency to believe that extra successful months are owed to us for our past bad luck, when in all actuality, it is just a stretch of positive variance. I'm not saying everybody, but I'm saying it happens a majority of the time to most players, at least at some point in time in their career. So, the thing is, we all have a lot of both positive and negative variance. But we don't often recognize the run good for what it is. It's simply run good. And this kind of leads to a tendency to overestimate our win rate. And if we're overestimating our win rate and then like having all this negative variance, is really going to mess with our minds. The thing is, poker's a high variance game. And most of the time, over small samples, we are either going to run good or run bad, but we're very rarely just going to run normal. So, some more examples. How likely is Sammy to run close to his win rate? Well, again, I'm going to break away and show you guys how to do something like this, but let's say that close means within 10% of his mean win rate. 10% of 2,000 is equal to 200, and 2,000 plus 200 is 22, minus 200 is 1,800. So what we're going to do is find a probability that Sammy's results will lie in a range of 1,800 to 2,200. We can't just say what are the chances that he wins exactly 2,000, because that's a bit too specific. We need to just say kind of what we mean when we're trying to find this. So we're trying to find somewhere in this range. Again, I'll go back here. Of course, our mean and standard deviation are the same, but we're trying to find between certain results. So we're trying to find between 1,800 and 2,200. If I can click on it. Okay, so then at the bottom you'll see the shaded area equals 7.2% approximately. So this is kind of most of what you can do with this, and you can also see what the probability is that Sammy lies below certain ranges. So you can see what his chances running worse than a certain number. Back to the presentation here. So you can see 7.2% of the time he will run within 10% of his win rate. So that's only 7.2% of the time. In 100,000 hands will he run pretty close to his win rate. This is what most poker players, I believe, would say, hey, that's a pretty large sample. But point is, it's not really that large because he's not going to run that close to his win rate very often, only 7.2% of the time. So this just goes to show how much variance there still is in poker, even over 100,000 hands. I mean, granted, that's a large number of hands, but it's not enough. So another example: how often will we break even? Same sort of process as the last example. I compute break even as lying between negative 500 and 500 BB, and he has about a 12% chance of ending up in that range. So what's interesting is he has an 18% chance of running hot, which is greater than 4000 BB, and a 12% chance of breaking even over his next 100k hands. These two results are pretty similar. So, Sammy's next month, he has pretty close to the same chance as running hot as he does to not winning anything. Again, over 100,000 hands. I mean, that's quite a bit right there, and still getting, some pretty different extremes in his results. What about losing? How often does he lose more than 5 buy-ins? 13% of the time. That's fairly often considered over 100,000 hands. I know I'm sounding like a broken record here, but 100,000 hands, you still got a 13% chance with a player with this win rate of losing at least 5 buy-ins. So, assuming the 100,000 hand must for Sammy, take a yearly breakdown. Look at these numbers. 2.2 months out of the year, on average, he'll run hot, win at least 4,000. 1.4 months, he'll have break even, which will be in that negative 500 to 500 range. And 1.6 months, he'll lose at least 5 buy-ins. The remaining 6.8 months, he'll be in that range of 500 to 4,000 BB. So, what can we see? About 30% of the time, Sammy has a run good month or a run bad month. It's one of those two. They're similarly likely, and the thing is, 30% of the time is fairly often. That's about, 4 months out of a year. So, even though the hot months occur about as frequently as the cold months, we tend to feel that the hot months are a more accurate depiction of our poker prowess. Again, this relates to the thinking that positive variance doesn't kind of exist for us poker players. It's an overestimation of our win rate, those sort of things. And if the thing is, if you're going to use that logic, that, then say, okay, well, running bad is about equally as likely, so shouldn't that be an accurate indicator of our poker prowess? Now, granted, sometimes we do feel that way, but what it really comes down to is neither of them are even close to a reliable indicator of how good we are. So, what it gets down to is all of those months where you feel like you did all right, but you could have done better, you probably ran pretty close to average. All those other months, that's run good and run bad. This is why poker can be so frustrating. Now, I've never done that, but I know people have. I've done that. And I'm pretty sure I've done that. Alright, so let's take a look at the dude. The dude is the guy who's crushing the stakes. So let's give him a win rate of 8 BB per 100 and a slightly larger standard deviation of 80 BB 100. Reason we're doing that is he is, since he's doing some high win rate, it follows that he is taking some more high variance plays. So his variance is, his standard deviation is going to go up some with his win rate. Let's say the dude plays 1 million hands a year. And the dude does everything a great poker player should do. He table selects well, he's completely tiltless, he's always on his A game. He is indeed the dude. So, how much can the dude's win rate vary just due to variance over 1 million hands? Well, we know how to do this. First, we calculate the mean over 1 million hands equals 80,000 BB, and the standard deviation equals 8,000 BB. Again, you'll notice largest sample size we've looked at yet, and look how much larger now his mean is as compared to his standard deviation. Now it's 10 times as much. So the results are going to converge on the mean even faster over 1 million hands as expected. So to see where 99.7% of our results will lie, we add 3 standard deviations to the mean, and we subtract 3 standard deviations from the mean. So 3 standard deviations will be 3 times 8,000, which the standard deviation is 8,000, and that's equal to 24,000. We both add and subtract this number from the mean of 80,000, and we get a range of 104,000 BB and 56,000 BB. So the best case scenario of 104,000 is the equivalent to the dude winning at 10.4 BB 100. This is 2 BB 100 over a million hands higher than his win rate. The worst case scenario of 56,000 is the equivalent of him winning at 5.6 BB 100, which is 2 BB-ish less than his win rate. Now notice these two results are 5 BB per 100 off. Again, over a million hands. Both scenarios are 30% away from the dude's actual win rate. Now a note on this. Of course, both of these results are outliers, but it does go to show how extreme our results can get over a really large sample size. And in fact, his results will lie in a range of the 9.6 to the 10.4, so that real high extreme, only 2% of the time. And his results will lie in that range of 5.6 to 6.4, only 2% of the time as well. But, having said that, 2% of the time isn't that unlikely. I mean, we've all had that happen at the table. So, it's not that unlikely. It is an outlier, but it's not that unlikely. 68% of the time, the dude will run within 10% of his actual win rate. So you can see the results definitely have converged on the mean as compared to Sammy Supernova, who was 7.2%, I believe, over 100,000 hands. Granted, you have a higher win rate here, so that's going to help that happen as well. So, but still, while it is 68% of the time, there still is 32% of the time that it won't fall within 10% of his actual win rate. So to put this kind of in context, if this were a 1-2 player, his yearly volume, it would be the difference between 208,000 and 112,000, just due to variance. I mean, this is $100,000 a year that the dude playing 1-2 can expect difference just in his variance. I mean, that's really extreme. So this just goes to show why professional poker players should absolutely have a large bankroll. Especially if they're taking money out of it, have a high monthly nut that they're taking out of their winnings. Because thing is, even if you're doing a really, really great job, like doing what we may even consider a perfect job, as well as can be expected, lots of results can happen. So if you're doing less than perfect, which we all are doing because we aren't the dude, then we need to account for that and knowing that our range will be bigger. So, you can't count on money being there automatically because it's not going to be automatic. There's a lot of variance. So some things we can learn from the dude. The dude, I've kind of touched on this a little bit. He's winning a high win rate, and even he can experience big swings. If you have a smaller win rate, you can expect even greater swings. Just be aware of that. Take that into consideration in your financial planning. Take that into consideration when you have those swings. Even a very good player can run quite hot over a large sample. which is nice. We like that. Um, Running hot and seeing really amazing results doesn't tell us as much as we would intuitively believe. You see a really high win rate doesn't necessarily mean that your win rate is that high. So a reasonable winner can look like the dude over a reasonably large sample. So don't let other players' amazing graphs get you down. It just, there's selection bias there, and we're going to touch on this real soon a little more deeply. And one thing to say here, and this is not to detract from, any of these players that have had this happen, it's just something to note to put it in context, that the guys who quickly ran to nosebleed stakes, while they're certainly an awesome player, and I'm not taking anything away from them, probably had some good luck on their side to do it as quickly as they did. Of course, it'd be easier to get these sort of awesome runs when you're playing in juicier games, which, they were several years ago. Because those juicier games are going to provide higher win rates, which, is going to lead to less negative variance and higher, swings in a faster period of time. So just keep that in mind. When you talk about players from years ago who had these exceptional runs, certainly they were studying and doing a great job, but, to have those exceptional runs, you're looking at the guys who probably caught some good variance as well. Those runs that occurred really, really quickly. So again, a note on pretty graphs. There's a lot of players out there, and a lot of them are playing a lot of hands. A hypothetical 6BB100 winner will have his next 300k hands run at 10BB100 just 1% of the time. However, if you consider how many players are out there, that most of them have statistical tracking software, and that many, if not all, will love to show off their pretty graphs, which who can blame them, it's not too far-fetched to imagine that you're going to see these graphs pop up from time to time. There's just enough players out there winning that there's going to be some sample sizes when that happens. And when it happens, that player is going to, that player is going to be a good player, like certainly. But it doesn't ensure that it's the best player in the game. It's not even close. There's a strong selection bias here, as poker players will rarely post their mediocre graphs, unless of course they can complain about how bad they're running. But the thing is, if a guy just has a normal looking graph, he's not going to post that. You're just going to see the post of the really, really extremes because, players want to show those. So there's a selection bias there. So don't let that get you down that all you see is lots of really pretty graphs. Most players' graphs just aren't that pretty. So, what about a solid good player? Just, more normal player. Say we have a player who wins at 6BB100 and a standard deviation of 70BB100 over 170,000 hands. So, we think this is probably a fairly close to accurate win rate. Then, this has probably happened to some of you. Your next 100,000 hands break even. So, how likely is a 6BB100 winner to, assuming we know that it's a 6BB100 winner, going to break even over his next 100k? Only 0.3% of the time. So, again, it's going to happen, but pretty low probability event. So, conversely, how likely will a break-even player win at 6BB100 over his next 100k hands? The studio notices this is going to end up being the same number, 0.3%. So what can we gather from this? Assuming that our observed 6BB100 winner is a strong player who studies and thinks about the game correctly, it is unlikely that he's actually a break-even player. It just isn't going to have these sort of results happen very much. However, it's also fairly unlikely that he is indeed a 6BB100 winner. He probably ran hot over that 170k hand sample. It's also fairly likely that his play is deteriorated due to his bad run, which causes win rate to go down, which causes the probability of bad runs to increase, which causes his play to deteriorate, which causes his win rate to go down, and you can see how this vicious cycle can keep going. So, point is, if we can become tolerant of it, we don't get in that cycle so much. And that's going to make our win rate go up. And essentially, if our win rate's going up, that's us being a better player. At the end of the day, that's what you're trying to do. So, to summarize, don't let your observed win rate influence your emotional state or your self-perception. Your observed win rate is unlikely to be accurate and it could have a lot of variance, and you can only judge yourself by keeping score your own way. Know how are you doing on your learning. That's how you judge. Are you making adjustments? Are you doing the things that good poker players do? Are you becoming a better poker player? That's what you judge yourself on. So we can really only assess our level of play via hand analysis and observation. You can also have, a pair of trusted eyes from a friend or posting on the forums at DC. That can help you, get other input and see how well you're doing, see how accurate your estimates are. All the stuff that makes a good poker player, you just keep working on it. Be aware of variance. Don't let it cloud your judgment or affect your learning. This is about that vicious cycle. Winning players run hot over large samples, and we will often, if not always, hear about them. So, don't count on your win rate being high. You never really know. And don't let that, again, you're going to run hot from time to time, and accept that. And don't let it build your ego up, and don't let other people doing that, make you feel bad about yourself again. I think I see this really a lot. We can see that the long run is really, really long. A million hands with a dude, still pretty wide results we could fall in. Definitely was going to win, but, And don't let the vicious cycle continue. Just, keep studying, keep learning, set goals that aren't related to results. More on this as we discussed in future episodes. The idea is not to become this guy. This is what we're going for. I hope this helped. I hope everything was clear. And if you have any questions, definitely let me know in the forums. And we're going to keep working at it, and we're going to discuss more things in the next episode. And I hope you guys enjoy it. So this is Strez13 signing off for the first episode of Tolerance. I'll see you guys in the forums.